Hi, welcome to our math. Today I'm doing a series of videos on inequalities and the absolute value of inequalities. Today I have two problems, and one thing I want to note about absolute value problems is whenever there's a number with the absolute value part of the problem, like this negative 14, you need to move it over so the absolute value part is alone. The other thing I want you to note is that you need to be really careful of negatives. So if we start with this problem, the absolute value is always positive. If this is always positive, so it is 0 to infinity, when is it less than a negative? So this is here, and I'm asking you the question, when is it here? And the answer is never. It is never over here because it's always positive. So this is no solution. So you always need to be really, really careful when you see a negative in a problem that's dealing with absolute value, because so often these problems have one of two ways. If this was greater than or equal, it would be all real, negative infinity to positive infinity, or it's no solution. But what happens is you'll start to go too fast. You'll see this is less than and it's all real and yay, I'm done, except you need to add the 14 over first. You cannot analyze it until you've added that 14 over, so that you have 6 minus 3x is less than or equal to 9, and now you can do the problem. Because it's absolute value, and the graph of an absolute value is a v, there's two solutions. So we need to find both solutions. The way you find the two solutions is you start off by writing it just as is. 6 minus 3x is less than or equal to 9. And then the second time you write it, you keep what's in the absolute value, 6 minus 3x, but then you flip everything. You flip your inequality, greater than or equal, and the number on the other side of the inequality, negative 9. That's because what's inside that absolute value, if this is 8, it works. If it's negative 8, well, obviously it would come out as a positive. So the thing is, if it's 10, it wouldn't work, but negative 10 would. So two answers will work because the positive and negative of this. So what we need to do is we need to solve it twice. We subtract 6, negative 3x is less than or equal to 3. We divide by a negative, and when we divide by a negative, we flip our inequality, so x is greater than or equal to negative 1. We subtract 6 from both sides. Negative 3x is greater than or equal to negative 15. We divide by negative 3. Flip our inequality, x is less than or equal to 5. Now for our graph, negative infinity, positive infinity, we put the negative 1, we put the 5, x is less than 5, greater than negative 1. If our sign is less than or greater than or less than, we use parentheses. If it's greater than or equal or less than or equal, we use brackets. Because we have the greater than and less than or equals, we're going to use brackets. That way, what is on our graph mirrors what will be on our interval notation. So our answer is going to be bracket negative 1, comma 5. All right, I hope you've enjoyed this video. Please subscribe to my YouTube channel, and I'll see you on the next video. Thank you.